Hey, thanks everyone. We're going to go ahead and get started. I wanted to welcome everyone and thank you for joining us for today's webinar. My name is Jen Weesey and I will be your moderator. I work with the Grails and Micronaut team here at Object Computing. And again, thank you for joining us. We are really excited for our guest presenter today, Guillaume LaForge. He's a developer advocate for Google and a member of the Micronaut Foundation Technology Advisory Board, and he is joining us all the way from Paris. So in this complimentary webinar, Guillaume is going to demonstrate some options that you have to deploy your Micronaut applications and services on Google Cloud without spending a lot of time on your infrastructure. Thank you again, and with that, I will pass it over to you, Guillaume.
Thank you very much. So it's my pleasure today to tell you that Micronaut is a great fit for the Google Cloud Platform, and in particular, the serverless solutions, as well as the reverse thing in the sense that both are great fit for each other. Micronaut, starts so fast, consumes low memory, so it's really great for serverless services that indeed need to start fast. So let me tell you a bit more about this. So as Jen said, if my clicker, wants to click. So yeah, I'm Guillaume. I'm pretty well known in the Groovy community for being the co-founder of the Groovy programming language back in the day in 2003. So that's a long time ago. I'm also a Java champion, and I'm pretty happy to be part of the tech advisory board for the Micronaut Foundation. This is really exciting, and there's lots of interesting stuff coming up on the roadmap. So really looking forward to see that next. So a few words about the Google Cloud Platform. It's a pretty big platform these days in the sense that there's really tons of regions, of zones, of network edge locations, etc. You can find the various services, databases, compute products, etc. Everywhere, and hopefully in a data center near you. And this is really just a little panorama of the stuff that's available, but there are many more products than this. I'm particularly interested today in the compute part, so that's why I'm going to show you App Engine, Cloud Run, Cloud Functions. I'm also going to use along the way some other products like, where is it? PubSub. Where is my PubSub? I think I'm missing PubSub. Where is it? No, it's forgot it in this slide. So yeah, there are tons of stuff missing. Things like PubSub. I'm going to use the Cloud Firestore database as well. Many useful things and services and APIs that you're able to use and mix and match within your Micronaut applications. So let's focus a little bit on those compute aspects. If you think about all that available, the various types of compute options that exist today, even outside the cloud itself, when you're on premises, on your own servers, you have to handle everything from the physical hardware or virtual hardware, the OS, any patch, security issues that you might have, you need to patch, etc. So you have to look at everything from the bottom up to your application, runtime application or functions. But as you move towards the right of this, let's say, diagram, you're kind of moving up the stack and you're focusing like on compute engine, you really focus on virtual machines. If you use something like Kubernetes engine, you're going to focus on the OS up to whatever's up there. And then you have platforms like Cloud Run. It's still a bit like Kubernetes in the sense that we're handling containers, but it's at a higher level. App Engine, now you don't need to focus about the app runtime, but just focus on the app, on the functions or services, microservices above. And same thing with Cloud Functions, where you really just focus on some units of code. So here today, we're particularly interested in this particular zone where we deploy apps, containers, and functions on the Google Cloud. A few words about the serverless buzzword. You can see it with two lenses or two angles. There's an operational model where indeed you don't focus on all the infrastructure management, so you don't have to provision servers, prepare your clusters, etc. All the security is handled for you by the platform. So Google Cloud handles all the security patches under the hood. And the key thing is the pay for usage model, in the sense that if your services are idle, they're not going to cost you anything because there's no traffic coming towards your services. Whereas if you, let's say you have a certain level of traffic and suddenly there's a spike, there's twice as much traffic, you're going to pay twice as much. So pretty much proportionally to the actual usage. And the underlying infrastructure is going to scale for you the various services. So scale down to 0 if nobody uses your services, or if it's like once a month, once a week, once every hour or something, up to 1 or up to many instances running in parallel if needs be. The other approach, that's the programming model. So with serverless solutions, you tend to focus more on finer grained services. Let's call them microservices. So you take a service-based approach to how you decouple the various important parts of your business logic and application code. We tend to write more event-driven code because you react to events coming up from the various services, from the cloud itself. And HTTP is also a kind of event. It's a synchronous event, but otherwise things like, let's say, a new file appearing on a cloud storage bucket, that's an event that can trigger something like a cloud function, for instance. The other thing as well is that we're trying as much as possible to be more open. And when I say more open, I mean open source, in the sense that the runtimes we create, or for example, for Cloud Run, the underlying APIs, the Knative APIs, are things that are open source, which don't lock you in this particular platform, but allows you to move those functions, those apps, those containers elsewhere as well, on premise or even on hybrid solutions. So the focus is on those 3 cloud functions: App Engine, Cloud Run. Cloud functions, it's really source-based, event-driven functions. So events like, as I said, a file on a cloud storage bucket, a message on a PubSub queue. You can also create custom events with cloud audit logs. So you can create some special logs that are going to trigger your functions. App Engine is more for things like web front ends or mobile backends, web APIs. There are some interesting characteristics to App Engine that are only coming up to Cloud Run. Things like its capability of serving things like static assets with a built-in CDN. That's something that's very powerful. If you have a single page app where you serve all your front-end code, HTML, JavaScript, CSS, etc., and then you call the backend APIs, you can serve those static assets very rapidly. That's something that's been there on App Engine for a very, very long time. And Cloud Run, I would say almost it's for anything else. That's not a runtime provided by the Cloud Functions or App Engine platform. Anything that runs in a container, and containers in general, container images that are portable across other platforms as well, such as running on Kubernetes or things like that. So now let's zoom in on Cloud Functions. So I mentioned already various sources of events, messages on PubSub, direct synchronous calls through the various HTTP methods. There are some useful services like Cloud Task or Cloud Scheduler, for example, where you can run your services on a schedule. So for example, you want to create a monthly report, or every time at midnight you want to compute some stats or something, you can use additional services which allow you to glue things together to glue your functions together. And yeah, from functions, you can use all the key services offered by the Google Cloud Platform. And something I wanted to mention as well, with Cloud Functions, it's often used in things like the Google Assistant, like if you have a Google Home at home, or you're creating your own chatbots for your e-commerce platform or something, you can use Google Assistant or the Dialogflow chatbot platform and configure Cloud Functions to react to this and have a conversation with your users via voice. So that's pretty cool. Until recently, Cloud Functions was available only for Node, Python, and Go, but we announced the beta for Java 11, and hopefully, well, I'm not supposed to give dates, but hopefully within the next few weeks or month at worst, you should have the general availability version of Java 11. We're going with Java 11 because that's the latest LTS, long-term support version of Java provided by Oracle. So we really try to focus on the highest level of maintenance, and why we're not like providing let's say Java 13, 14, whatever. So you can now write functions in Java. There are two kinds of functions. So synchronous functions, which are HTTP functions, which can react to get, post, put, delete options method calls. The Google Cloud Platform, Google Cloud Functions Platform provides a URL for your functions directly, so you don't have to configure some domain name or something like this. You have a URL that you can invoke from other places or other services as a webhook, like things like a GitHub commit hook, for example, that could ping your Cloud Function when someone commits something or creates a pull request, For HTTP functions, you can access the header, the body, you can provide a status code in the response, you can use writers or streams, octet streams. And you also have the proper background functions, which are even more asynchronously event-oriented. That's the ones which react to cloud-related events, WhatsApp messages, new file on cloud storage, etc. Or yeah, I did mention that what the Cloud Firestore, NoSQL document database, you can get your function triggered when someone changes something in the database, which can be interesting if you want to be notified of a new line, a new order, or any new entity in your database. Before moving to App Engine, let me show you a couple of things. So for I need to get back off full screen. The goal of this webinar, obviously, is to show Micronaut in action and running on those great serverless platforms. So I prepared some little demos. And for those demos, I actually just started with the Micronaut launch tool, right? So all the samples, so I tweaked some of them to add like a Gradle plugin or like a dependency or things like that, some additional configuration tweaks. But otherwise, what's great is that with Micronaut launch, so you can create applications, you can create functions, you can add features. There's a dedicated Google Cloud Functions feature that can be added. And then you can choose Java, Kotlin, Groovy as the programming language. You can choose your build tool. You can use your testing framework and even preview the stuff. So for example, here I have a default pops-up message-driven function that's created. And in the builder Gradle, you have everything that is set up properly. For example, there's even an invoker that's an API that's provided by the Cloud Functions team to allow you to run functions locally, which is pretty useful. And things, what else I wanted to show you? Yeah, let me show you this, a couple first functions that I've created with the Micronaut launch platform. So I've already deployed them here. So I have two functions created with Micronaut. the hello world kind of function that is using HTTP functions, and also a function which is triggered by a pub sub message. So let's start, let's say, with the hello function. Okay, so I, again, generated a template project thanks to Micronaut launch. I think I configured, what did I configure? Let me show you. I think I added one thing which we document on the, what do we call, the Cloud Functions framework. That's the API. And it's also documented in the Cloud Functions support in the Micronaut documentation, by the way. So I added this task, which allows me to run functions locally on my machine without having to deploy, which is super useful. Let me show you my hello controller. So it's a very simple controller. I'm going to listen on /hello and just say example response. So let me, am I in the correct directory? Yes, Gradle, run function. And I think by default, oh, I think I might have to, no, it's okay. I don't have to define the default function. Let me copy and paste localhost. So I need to go to /hello where my controller is, and this function is running locally without me having to deploy it in the cloud. Oh, there's a, what's going on? Some stack trace, error encoding object, although it worked, I don't know. I guess that was for the previous, the call which wasn't on /hello. And something I would like to say is, let's say, on Micronaut response, I'm going to change something here. Micronaut, just to show that all those that know Micronaut know that already, but for me, just making a small change to a function and seeing the function live already with the change applied, that's really something that I totally love. And so deploying a function can take a little while. Let me copy and paste a few things. So I can create, so there are two ways to deploy functions, whether it's with jar or with from sources. So it's possible to also run from sources. Either a function, or in general, not necessarily a Micronaut function, but a Java project or Groovy or whatever that's built with Maven or Gradle can be deployed and built from sources within the cloud. So on Google Cloud Build, and it's going to deploy that on the Cloud Functions runtime. So deployment of a function take like 1 or 2 minutes. Let me see, so what's the URL? That's gonna be, let me go to the Cloud Console. Yeah, I didn't show you the Google Cloud Console. So that's the Google Cloud Console, that's the UI. You have the command line tools that you can use. There's a dedicated Cloud Functions section here. You can see that my hello function is currently deploying. Well, I can show you just quickly, even if it's the previous version till the other one is deployed. So you have some stats here, you can see some sources, you can test here as well. And automatically there's a URL that is provided for you. So the URL is, I think I need to do a double hello actually, because otherwise that's going to be the home page. So you can see that that's my new, oh, wow, that's cool because it just uploaded right at the right moment. So that's cool. Micronaut response, that's the little change I made to my Micronaut controller. So the URL that's provided, I'm based in Europe, so I used Europe West 1. The name of my project, Serverless Micronaut, and then cloudfunctions.net/hello, that's the name, the symbolic name of my function, and hello, that's the name of my controller. So really, it's fairly easy to deploy a function, and I really, what I like is that, in particular, when you use HTTP functions, you're actually developing a Micronaut controller. And this Micronaut controller, it's just a plain Micronaut controller. So you can run that on, elsewhere as a standalone jar somewhere, or on another cloud platform, anywhere you can run a JVM. But here, thanks to the work that the Micronaut team did, they actually wrap the underlying Java Functions APIs to allow you, Micronaut developers, to create controllers just the way you're used to create controllers. And that way you have an HTTP function that's a plain Micronaut controller. So that's pretty cool. The other function that I have created, so function hello, I'm going to show you, I can save that one. I'm going to show you a pub/sub function. So again, generated with Micronaut Launch, and I only added, so I think I didn't change anything on that one. Yes. Yeah. So the sole thing I changed compared to the default function, I slightly changed this one, I think, or not even. I think that's the one from the documentation or something. No, it's a little bit different because I tweaked. So let me explain you the code. So I tweaked the example that's generated. When you receive a pub/sub message, so pub/sub is really a queue system, a message broker, so that your various services interact with each other. It's a communication channel for your services. And it provides topics. You can filter messages across those topics, etc. You can create subscriptions. You can do things like retries when something is not like your service failed and you want the message to be retried till it succeeds. Or what else? There are some super powerful capabilities with Cloud pub/sub, things like being able to replay. So let's say production crashed, and then you can create snapshots on a regular basis and replay past messages to get to a great state. So what I changed, I think, was this, where I'm using the I'm decoding the payload of the pub/sub message, because there's an envelope around the message, and there's a data, that's this one, the data attribute, and I'm going to decode that because it's encoded in base 64. And what else I did, and I'm really just like logging the message. I'm not really doing anything really fancy here. So let me show, oh yeah, on the, so here, we're actually implementing the Cloud Functions Java API. So that's a background function, which is generated with a pub/sub message. And the thing that's added that is specific, let's say, to Micronaut compared to a Cloud Function, raw Cloud Function outside of the scope of Micronaut, is that there's this Micronaut integration. That's the feature that we added in the Micronaut Launch template. And what it does is that it allows you to wire all the things, basically. So things like @inject, it's going to inject my service, my dump service that is there. It's going to inject that in my Cloud Function. So just a quick demo. Let me show you pub/sub. Pub/sub is here. I have a topic. So what do? I'm just saying, yeah, I'm just putting the output, raw output without any particular message. So I'm going to publish a new message. Hello, Micronaut developers. Let's go serverless, whatever. I'm going to publish that message. Up, it's published. And then I'm going to look into logging. That's where I can see what happened. And by default, so I can configure logging more properly with logback and everything. But here, when you do systemout.println, it's going to print on the logging platform. So the systemout stream is retrieved and redirected to the logging platform. So I need to go to Cloud Functions. And my function, yeah, should be here. And right at the bottom, you should be able to see here, hello, Micronaut developers, let's go serverless. That's the message we just received. So it's really easy to create functions. I think that's about it for functions. And yeah, other kind of functions, as I said, you can react to new messages on Firestore databases. Cloud audit logs, you can create specific audit log messages, etc. So you can react to all sorts of events. Let me move back to the slides here. Need to hurry up a little bit, I think. App Engine. App Engine is the way you deploy apps, mobile backend, web APIs, serve static asset, things like that. So it's I would say it's the oldest serverless solutions provided by Google Cloud. And it's funny because, so it was released in 2008. Back then it was platform as a service, but it exhibited all the serverless characteristics that we explained in introduction. So pay as you go, etc. All those things were already there. And the funny thing was that in 2009, when they released the Java runtime, I worked with so I wasn't working for Google back then. We were working for a little company called G21, which was providing services around Groovy, Grails. Micronaut wasn't there yet. And Google actually asked us whether we could ensure that alternative languages like the Groovy programming language would run well on App Engine. So that was my first foray into this App Engine platform. And I've been using it for, well, since 2009, like for my own blogs and things like that, my own blog platform. So what's great, so we focused on functions. Now it's a little more, let's say, a bigger level of granularity. You deploy apps on App Engine. So you focus again on the code, on the app, and that's the platform that's going to handle the rest for you, the scaling from to 0 to 1 to n. There are different runtimes that are available. Currently, we, again, just like for Cloud Functions, we went with Java 11, which is the latest long-term maintenance support version. And what else? Some of the cool stuff that I like about App Engine compared to Cloud Function, that's the fact that Cloud Functions, there's a concurrency level of 1, meaning that there cannot be 2 concurrent or more requests coming to one function at a given time. So it needs to spin up many instances. Whereas with App Engine and also Cloud Run, as we shall see later on, one application can serve 80 concurrent requests at the same time. And after those 80 concurrent requests, it's going to spin up a new instance of that service. So 80 plus 80, and you can have potentially hundreds of instances serving your application. The other thing which is interesting with App Engine is that you can cut your apps into services, and your services can actually scale differently and have different scaling capabilities as well. And the other thing that's interesting, I forgot if I think I can show you that actually before showing any code. If I go to the App Engine console here in the Cloud console, you can see like the various versions of, I currently have only one service that is deployed, but I have several versions that are deployed. So I don't think I made any changes to those particular versions. But for Cloud Run, I'll show you how to do things like the fact that you can have several versions of different services. You can do things like gradual rollouts, blue-green canary deployments, etc. You can do that kind of stuff, or serve different versions. For example, for your QA team, you want to have the QA validate that the new version is great. Okay, they're going to do their tests, etc. We get the green light, then we can switch and change the traffic and say, okay, I want to change the traffic. So I can split different ways through IP addresses, with cookie at random, etc. And I can say, so across different versions. So let's say I want to have a 30% of traffic serving this particular application version, sorry, of the service or not. That's that's pretty cool and useful. And for example, for those who've perhaps used the Groovy web console, that's a way to run snippets of Groovy code online on the web. For example, I deployed different versions of the console of the web console, the Groovy console, to serve different versions of Groovy, for example. So that's a handy usage of that capability. Yeah, and let me go back here.
Hey, Guillaume, pardon the interruption, but there's a question related to some of that in the chat that now might be a good time to address. So there's a question that is, can you see the question?
Yeah, so are there dynamic routing policies available for traffic management based on conditions? So conditions, not really. So as you could see, like the traffic splitting I was doing, that's really like cookies, IP addresses, random, etc. But custom conditions, no. That said, there's something that is pretty new, but it's only in beta right now, which is, so we have a global cloud load balancer that now understands our serverless products, and that allows you to do things like provide traffic to, let's say, a function, an app, a container that's in a particular region because that's the region you're in. So if you want to have geographically traffic distribution or things like that. So there are some options now. I'm not showing that in this presentation. It's definitely more advanced. But there are some options around more fine-grained controls. So things are coming, but it's still fairly new, I would say, in this area, especially for our serverless products. So it's brand new. So I encourage you to look at, I guess I can show you if I find serverless. Yeah, so this one, and there was a blog post as well, actually, about it. So this is the documentation, but there was a serverless network endpoint. No, so that's again the documentation. That's not the link I wanted. But yeah, you might have a look at this to see what you can do or not in terms of control of traffic, etc. So have a look at this. All right, let's continue. Yeah, and the other thing I wanted to mention, that's the CDN static asset serving. So I don't think I've configured it for this application that I'm going to show you next. App Engine, front end, SRC, and Appable. Yeah, I didn't configure the static assets. The static assets, what's interesting with, so let me go back just in full screen mode for a few seconds. When you use a serverless platform, once in a while, especially when you scale from 0 to 1, or when there's a sudden peak of traffic and the platform needs to create more instances of your services, you may experience cold starts. That means that in addition to have your new instance of your application being started, so there's your own startup time, but there's also the platform startup time that creates the instances to run your application. So you may face a few hundred milliseconds or a few seconds potentially max of time before traffic is served. And I was saying in introduction, I think what's great is that, especially nowadays where we tend to write more apps like serverless, single page applications and things like that, with React, Vue.js, Angular, and all those new cool frameworks. What's great is that with those things, or even with server-side rendering, where you have static assets and you do progressive enhancements and things like that. You serve static assets in no time with a platform like App Engine, because you can do static asset solving from CDNs, from content delivery networks. So that means that even if your instances are not yet ready to serve business logic traffic, at least your front end is ready and is already solving, and then you can call your backend, and it's going to be, I mean, the call starts will be not really visible to your end users, which is something that's pretty cool. And we're working on that as well for Cloud Run, but it's fairly new, whereas App Engine provided that since, well, pretty much the beginning of the platform. So again, I wanted to show you, so it's really just a Micronaut application. What I did here, so I really only have like a single controller. There's a dummy page that says Hello Google Cloud. And just for the fun, I wanted to show you that you can use a database. Here I used Cloud Firestore. And let me show you what it's going to do. So app, what's my, perhaps I have it running somewhere. That's, no, that's Cloud Functions. Yeah, this one. So this one is my App Engine application running. It's, so there's really, the instances currently, there's like, there were 0 instances because there was no traffic coming up, but now there's one that's been created to serve my traffic. So which tab was it? That was this one. So let me do this and move that here. That'll be easier for me. I have some dashboard, like stats and such, and my service that is here, and I deployed already 4 versions. If I go here, so that's my controller here, that's really just the index, and that says Hello Google Cloud. Okay, and I also created another endpoint here that is actually using Cloud Firestore. So Cloud Firestore, here I'm configuring the Cloud Firestore NoSQL database to have access to my collection of pets. And I'm doing a snapshot of the data that's stored in this collection. And then I'm going to return the name of my pets. Oh, there was a little problem. Don't know what happened. I need to look into the logs to see if something went wrong. No, I don't know. Well, I don't want to waste too much time figuring this out, but yeah, in my Firestore database, let me show you Firestore quickly. I have a couple of pets. Yeah, pets, Shuket, that's my cat, and Toby, a dog, but I don't have a dog. I prefer cat. So these are the 2 documents that are served here, and I just returned. So I should have used a proper like JSON rendering view, etc. But I went with something a bit of a hack with just a string builder. But you know, it's very easy to configure extra databases. So I just imported Firestore. I added in the build.gradle. I added where is it? This one here, the Firestore dependency, and then I was able to create this little query to find all the pets in my data store. Yeah, that's about it. Let me go back here. I think I just wanted to check something. Yeah, I'm staging and deploying. Yeah, that's, did I want to say something? Yeah, oh yeah, something I wanted to mention. I knew I wanted to say something about the build. Build at Gradle. Where is it? It's at the top. So compared to what I generated with Micronaut Launch, just again to do a parallel with what is being scaffolded for you, in my build.gradle, I added this configuration for the App Engine Gradle plugin that allows me to prepare the deployment of an App Engine application and that works totally fine with Micronaut. So I'm using that plugin, and I want to use the shadow jar, and I don't want to use the non-shady jar. So I just tweak this build a little bit to just deploy the shadow jar named after the standard jar, so that when I actually deploy, so that was my cheat sheet here, I can use the App Engine plugin to say App Engine stage, and it's going to create for me, I think I might have a finder somewhere that can show you that App Engine. In the build, I have a staged app here that contains my shaded jar here. Oh yeah, I didn't show you the app.yaml file as well. That's the app.yaml specific file, configuration file. And the sole thing I did here to say, in addition to adding the plugin, but that's really just to, I don't need the plugin per se, but it creates the staging area for me, etc. In addition to what Micronaut Launch creates, I just added in SRC main app engine app.yaml, I added this app.yaml file with runtime Java 11 to say, this is a Java 11 app engine application that I'm deploying. That's all I'm doing to deploy my application, my Micronaut application on App Engine. So we've already seen that App Engine runs, Micronaut runs as functions, background functions, HTTP functions. We've seen that App Engine, again, Micronaut runs as an App Engine application. And now we'll have a look at, we'll finish with Cloud Run to say that you can also deploy Micronaut applications containerized on the Cloud Run platform. So Cloud Run, it's a new take on serverless. So there was past platform as a service, things like App Engine, Heroku, etc., where you were focusing on apps that you were deploying on some platforms. Often people think about serverless as function as a service, but it's really just not, it's not limited to things like cloud functions or AWS Lambda, Azure functions, etc., Oracle FN functions, etc. No, serverlessly, you can also deploy containers. And the idea behind Cloud Run is that you can have the very same characteristics and attributes as all those serverless platforms, but deploy, run container images. And what's great is that with Cloud Run, you can run anything. So you can run even binaries, you can run any language, any runtime, any library. And there's a wealth of a huge ecosystem of base images that are already readily available. And I'm also interested, obviously, in the Java platform at large, but in particular, Micronaut, of course. So we're going to deploy Micronaut. We're going to containerize Micronaut apps and deploy that on Cloud Run. A few more words as well is that Cloud Run is based on some open API, an open source project called Knative, which allows you to run containerized workloads on things like Kubernetes engine or other Kubernetes-based platforms, and also on things like Anthos, which is the hybrid cloud solutions provided by Google Cloud, so that you can run the same payloads on premises, on your own cluster, on another cloud than Google Cloud, on Google Cloud itself, etc. So I'm just not saying much more than this. A container has to follow a certain contract, so you have to listen. So it's really HTTP-based workloads that those container receive. So you listen on 000 on port 8080 by default, but you should be listening to the $port environment variable. Servers must start in less than 4 minutes, but for serverless workloads, I think that's a good thing to start even more fast than this, and even faster. Currently, you cannot run anything longer than 15 minutes. The default is 5, but currently we're also, I think it's in beta right now. If you can join the beta to request longer request time, request duration, so that you can run up to 1 hour. Okay. Oops, sorry. So yeah, it's about stateless containers. So don't put things like a database in your container. You'd better use external services for that, because at some point your container image might be shut down because there's no traffic, and spin up again at a later point when there's traffic that's coming back. And in that case, you would lose anything that's in memory, if it's a database or on the file system, etc. And also things like having background activities, like background thread, etc. The background thread might be stopped as well, because it's really your instance is running only when there's an incoming HTTP request coming to your container, and the background threads and such might be just shut down once your request finished serving. So avoid things like background activity. What's great with Cloud Run, again, with the pay-as-you-go approach, is that you're really billed by 100 of milliseconds, so not more. It's a small increment, and so it's proportional to the quantity of CPU, memory, number of requests. But the nice thing with the billing is that it's not like, let's say you have a request that takes 100 milliseconds. You're not going to be billed for each request that takes 100 milliseconds, but rather it's the time your instance running your request that is starting and serving traffic till the end of the last incoming request, and you've finished serving traffic to that last request. So it's not the, let's say, the green time plus the red time, the time the first request, the span of the first request plus the span of the second request, but it's really the overall time the first request started and the last request ended. So you're billed just for that, not just for each piece and slice of 100 of milliseconds. Before the summary, let me show you my Cloud Run Micronaut application. So I'm going to close a few things. Can close this and that. Okay. Cloud Run, I'm going to close that. Just want to see Cloud Run. Perfect. So when you create a Micronaut application, again with Micronaut.launch, what's cool is that you even have a Docker file that's created for you. So you can use that and deploy your Micronaut application bundled within a container with the provided Docker file. So it's a possibility. But there's another thing I wanted to experiment here now that I wanted to show you during this webinar. It's the use of the Jib plugin. What's great with Jib, it's an opinionated way to containerize Java applications. So you don't have to mess with Docker files yourself. You don't have to touch Docker files, although this one is just, fine. But I'm going to show you first the build.gradle for my Cloud Run application. So what is it? It's not this one. Looks like I forget to change this thing that was for my App Engine application. Okay, so I added the Jib plugin, which allows me to configure my Micronaut Gradle build. Where's Jib? It's here. To say, okay, so I want to let this Jib Gradle plugin create a proper Docker file for me, using and deploying my Docker container image into the gcr.io, that's a Google container registry where you can upload, it's like Docker Hub basically, but hosted on the Google Cloud Platform. So you can deploy your container images there. And you can also customize the way the Docker file under the hood is going to be created. For example, here, I will need to use OpenJDK 14 Alpine. Okay, so far, remember with Cloud Functions and App Engine, we were using the Java 11 LTS versions, but here inside a container, I can write anything I want. So I can choose, control of the version of Java I want to use. So if I want to use the very latest and greatest JVM, because I want to use, I don't know, Java records or anything like that, I can customize here easily with just a bit of configuration in my Gradle build file for my Micronaut app, the way my container is going to be built. So here I'm not using this Docker file. I let the Jib plugin do that for me. And I'm going to show you my, I actually have a couple of controllers. So I have a welcome controller and a news controller. If you remember what we did with App Engine and when we spoke about things like traffic management, etc., blue-green deployments, and so on. So what I did is that I deployed actually 2 versions of my Micronaut application. So that there's one that's going to serve style color blue, and the other one was actually serving style color green. So if I go, is it running somewhere? Yes, so this one, well, it's running with green. Let me show you. Let me go to the Cloud Run Cloud Console UI. So I deployed already my Cloud Run service, my Micronaut application, and you will see I have different revisions here. The 2 green ones there, with the check marks, that I deployed an hour ago. But I added some tags. So I can say there's a blue version and a green version. So currently that's, well, that was the blue version serving, right? Yeah, that's the blue serving. I'm going to close a few other things, but I can use tags. So let me get, so if you look at the URL here that is provided, it happens, oops, it happens green dash 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 or blue dash 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 to the URL. So let me click on both. And so I have my blue deployment and I have my green deployment. So I can do things like traffic splitting, canary deployment, and so on, and blue-green deployment if I want. And I can, oh yeah, the other thing I haven't used it, but that's cool and that's new, that you can set up continuous deployment. So as soon as you deploy a new container image, it can auto deploy as well on Google Cloud Run, which is pretty cool. And there was one last thing I wanted to show you, which is, so it's something that is in alpha, but it's going to be in beta in the coming weeks. On Cloud Functions and App Engine, you cannot do things like streaming, WebSocket, server-side events, gRPC streaming, etc. It's not possible because there's a kind of server, the Google front-end server, that receives all the requests globally for all the applications, that buffers all the incoming requests. But for Cloud Run, that's something that's changing. And we allow streaming requests as well. So your project needs currently to be whitelisted to get onto the alpha, but in the coming weeks, it's going to be public. So for the fun, I wanted to test the server-sent event support provided by Micronaut. So I created a news controller. I'm using a publisher here to say I want to stream to do so media type text event stream. That's the server-sent event mechanism. And then I'm using a Flowable to send a few messages, like one every second. And something like this, you couldn't do that with functions or App Engine, but it's something that's new in Cloud Run. And if I go, so I opened it, where is it now? here, so it's already deployed. So I'm going to reload. It's going to stream the results one at a time, one every second. So if you want to do things like, chat apps or have live feedback of things going on in your application and the underlying data, now you can use things like streaming, gRPC streaming, server sent events, etc. So that's about it. You can do lots of stuff with, you can run Micronaut on all those serverless solutions on Google Cloud Platform. So you can run Micronaut functions, Micronaut apps, Micronaut containers, or containerized Micronaut apps on App Engine, Cloud Functions, and Cloud Run. And you can take advantage of the various, data storage mechanisms or communication channels like PubSub. There are tons of useful machine learning APIs that you can take advantage of. And why use Micronaut on those on this platform? Because Micronaut starts super fast, faster than anything on Earth, and it consumes less memory. So it's going to cost you less. It's going to use less resources, and that's really awesome. So that's about it. Thanks a lot for your attention. And wow, already 1 hour has passed already.
Thank you so much for joining us. Thank you again for your time. We really appreciate having you. And it was a lovely presentation. So thanks again.
Thank you very much. Goodbye.
Bye. Thank you.